go to your browser and type SAS Studio. Then click on SAS on Demand for Academics. On the top right, you will see the button Access Now. And then again on the top right, you will see the button Sign In. If you do not have a SAS profile, you can go here, Don't Have a SAS Profile, and create your SAS profile here. It will send an email to your account. You can confirm over there, and once you have a SAS profile, you can come back to this page and enter your information along with the password, accept the terms, and click sign in. It will take a few seconds to launch SAS Studio. Sorry, there is another step. Go ahead and hit on launch. So then it will take a few seconds to launch the SAS Studio. It's a large program, so it will take a few seconds to upload. So here is the SAS Studio where we will be working next rest of our course. SAS has several programming interfaces that can be used to interactively write and submit code. Number one is the SAS windowing environment. It is the SAS main product. First off, it is extremely expensive, something like $2,000 per year per user license. It installs on the computer and can access data directly on your computer. It is the go-to statistical analysis software for the companies who are concerned with the privacy of their data, such as healthcare and government agencies, and also the medical research organizations like pharma industry. SAS Enterprise Guide, I have not used it, but what I know is a window client application that runs on your PC and access SAS on local or remote servers. SAS Studio is the prettiest of all. It is a web-based interface of SAS that you can use on any computer with internet. This is the interface that we will be using in our course. It is by far the most advanced software even within the SAS family. It has recently been converted to a total web-based application. Previously, it had a PC-based client too. The advantages of using SAS Studio are that being a web-based, you can access your account data from any computer. Once the data is uploaded, you can work on it wherever you are, at office, home, or even on vacation at Cancun, Timbuktu, anywhere in the world. It is very user-friendly because of the point-and-click functionality. That means you do not need to learn code. That is really a big deal. And it makes it superior to its competitor like R and Python. Please go ahead and pause this video here and log into your SAS Studio if you are not there yet, and let the fun begin. Once logged into the SAS Studio, you will see mainly two parts. On the right, you will see the work area, and on the left is what we call the navigation pane. Work area is where most of your work is done. Here, the coders will write code to manipulate or analyze data. But it is the navigation pane where all the support material and tools are available to support your work. SAS Studio has the capability to generate codes for you if you are using point-and-click functionality available in the navigation pane, as we will see in a minute. At some point in the course, once we are familiar with the software, we will learn at least maybe 10 or 11 most frequently used codes. Let's move to the navigation pane where we will be residing most of the time. If you see closely, there are 5 drop-down lists. First is server files and folders, as the name suggests, stores your data. Please go ahead and open it up by clicking on the arrowheads before the heading. This is where you upload data and save all your data during and after working on it. This area is of course not available in main SAS windowing environment. Can you think of the reason? Because SAS windowing environment installs on your PC and access data directly from the PC folders. In contrast, a SAS Studio being web-based can access data only if it is uploaded here. As you can see, I have dozens of data sets and analyzed data saved here. And you will have a bunch of similar data sets populating your server files and folders in next few days as we progress in this course. Next drop down is task and utilities. Again, we will be using this quite extensively during our course. Here we find dozens and dozens of ready-made codes already available. And this is the area that makes SAS so much fun and easy to use. For example, if I click on graphs and I want to create a bar chart, it will give me a wizard to create a bar chart from the data I have already uploaded. And you do not need to learn complex code because SAS has them already prepared for you here. You just have to point and click or plug and play. And to tell you the truth, I'm using SAS for a few years now, on and off. And I still use this because so many of the codes are simply too long to remember. Please go ahead and open the main sections. The third drop down is snippets. These are half-baked codes for you to edit them according to your need. Consider tasks and utilities as fully cooked or baked food from a restaurant or a grocery store, a cake or a burger or chicken curry, etc. And work area is where you write codes. It is like a uncooked food in a kitchen where you prepare food from a scratch as you want. If you want to bake a cake, you take each and every ingredient separately, such as eggs, flour, baking powder, sugar, and bake it the way you want. And task and utilities, as I said, is a fully baked cake from a restaurant, and snippets are like half cooked. You might get a mixture of cake and then you bake it at home, etc. So these are like ready-made codes, but you can manipulate them for your own use. Work area codes, whether you wrote them or they are generated by task and utilities or through snippets, do not have direct access to your files and folders. whether you uploaded them over here or in case of SAS windowing environment, they are on your computers. All files and folders should be connected to the libraries for the SAS work area to access them. Consider files and folders as your kitchen pantry. You cannot cook directly from the pantry, of course. It will be very weird. And my boss, aka my wife, will not be happy if I do that. You need to bring all the material to the kitchen table or a stove to prepare and cook. Libraries are like those tables or counters or stove. You need to connect your data to libraries first for SAS to work on them. In this video, we will first create a new folder in the server files and folder section. Then we will create a new library for this particular folder. This library will help SAS to work on the files saved in the folder we just created. And next, we will upload data in Excel format in the newly created folder. And finally, we will convert it to the SAS format. So let's get started. To create a new folder, click on Server Files and Folders to open it. Click on this ODAWS thingy to open this one too. In Files, Home, right-click, then New, and then Folder. Name the folder whatever you want. I have named it Epidemiology, Epid for Epidemiology, and then hit Save. To create a new library for the Epid folder we just created, right-click on the Epid folder you just created and hit Create, then Library. It will pop open another window. In naming a new library, there are two rules. Number one is that it should be 8 or less alphanumeric characters or an underscore. 8 or less alphanumeric characters or underscore. And number two is that first character cannot be a number. Let's name our new folder as Epid. We name it so we know which folder this library is representing. Please also check recreate this library at the startup. We will learn later what it means. For this course, we will be using Framingham Heart Study dataset. It can be downloaded from the SAS Studio itself. For that, you can go to Libraries, My Library, and then SAS Help, and scroll down to Heart over here. To download it, first you have to export it to any of the folder you have created. I'm gonna upload it to the folder which I just created, Epid, as a CSV file, but you have a bunch of other options. Let's download it as a XLS file, and then I hit export. I'm sorry, first click on Epid and then export. There is a folder already there. Let's replace it just for the sake of learning. And then when we go to Epid, here is the Heart folder that we just uploaded here, the XLS file. And you can just download it to your computer for future use, or you can just keep it over here for the practice of this course. If we hit download, it goes into our computer download file, and we can see it here, and we can open it up here, over here. To upload a file from your computer, you can go to any of the folders you created within the SAS Studio, for example, the one which we just created, the Epid. We go there, right click on it, go down to upload files, and then browse to the folder wherever it is saved in your computer. For example, this is the Heart the file we just downloaded. We're going to upload it right back into the Epid folder. Click on it, open, and then it is going to the folder home dr Farouk's slash Epid. Upload. It is telling me that it is another file with the same name already existing, and do I want to replace it with this file? I will go ahead and replace it again for the sake of learning, and we see it being uploaded over here. To convert an Excel file into SAS format, simply double-click on it. It will create a code in the work area, as you see on the right. First off, on the top, you see the source file information. The file name is heart.xlsx. It is stored in home/drfarouk/epid. There is only one worksheet, so we do not need to name the worksheet which we want to convert to SAS format. But what we do want to change is the output data. We do not want this file to be named import, and we do not want to save it under work, because work is a temporary library. So hit change. That will open up a pop-up window. We will save our new SAS formatted heart file in Epid, the library which we created previously, and we are going to name this file as heart, and then hit save, and then click on the run button on the top. It will run the code, and if you see on the navigation pane on the left, here is the heart.7 bdat file has already been created here. Now we will learn 10 or 11 most frequently used codes. For this course, you are not required to learn the SAS programming language. So you have the option to just watch and follow along, or you can just watch only for now. And maybe you would like to just watch now and practice later. And you have the full option to skip it altogether. But I will highly recommend that you at least watch this video for now, and do practice it at some stage when you are fully comfortable with the SAS functions. I'm recommending this for the following reason. If you master these 11 most frequently used codes, which you should not take more than an hour or so, you have my permission to add it to your resume to be a SAS programmer, at least a beginner. And to tell you the truth, nobody can challenge it. And honestly, most SAS users also only know these 10, 11 codes, and then they Google most of the others, which are the complex ones. The more complex codes are, number one, less frequently used, and they are very difficult to remember because coding itself is use it or lose it kind of a skill. So even the advanced users almost always forget them, or they write it somewhere. Second reason is that understanding these codes will give you a broad understanding of the structure of the SAS coding. And third, you will have the ability to tweak the ready-made complex codes which are generated by by the SAS itself, as we saw previously through the navigation pan. And by tweaking these codes, you can build up your further knowledge of the SAS coding based on these 10, 11 most frequently used codes. At the core of all the SAS is a SAS programming language. A SAS programming language consists of a sequence of steps. SAS programming has mainly two types of steps, a data step or a proc step. The data step normally result in the changes in the data itself. For example, if you want to create a new variable by multiplying two existing variables, or you want to convert existing variable to a different unit, that's where we will use the data step. And the second type of SAS programming step is the proc step, which conducts a procedure. For example, you want to get the mean of a variable, or more complex procedures like running a statistical function on it. So the SAS steps will mostly start with any of these two words, data or the word proc, and they end in the word run. And within each step, there are a sequence of statements which tells SAS what to do. But each statement ends with a semicolon. Pretty simple, right? Let's write a few SAS codes. Once you have uploaded your data on SAS, and before you start working on the data, the first thing that you need to do is to tell SAS where your data is located. And that is what you do through creating the library within the SAS. We know we already learned how to create a library by point and click method. Let me refresh your memories. We went to the folder where we have saved our files. You right click on it, you go to create, you create a library and name it according to the two principles. Number one being two rules. Number one being it has to be 8 or less alphanumeric characters, and or an underscore. And number two, it cannot start with a number. And it created a library append here. In fact, I have deleted that library to recreate it through a SAS code. And so let's do it by creating a library through the SAS code. In the work area, write libname. And as you can see, SAS is already prompting me. Next, name your library according to the two rules which we already read. Number one being 8 alphanumeric words or underscore, and number two, it cannot start with a number. So let's name it append underscore lib. So these are 8 alphanumeric characters. And next, what you have to tell SAS is where your files are located. To see what is the location of your files, go back to the folder where they are saved, right click on the folder, go to properties, and here is the location of your files. Just highlight, Control C, close, and within quotes you have to provide the location of these files. As you see, once you hit one colon, SAS will create the second colon by itself because it has to be enclosed within two colons. And as is the rule, you end your statement with a semicolon and then you hit save. You check the log and it says that the EpidLab has successfully been assigned. You go and check in libraries, my libraries, and here your library has already been created. Please remember that any libraries other than those created by SAS as default libraries are deleted at the end of the sessions. And that is when you log out of SAS, and all these libraries which you created will be deleted. If you want them to be, okay, let's see if they are deleted or not. For example, if we sign out and then we sign right back in, you will see that our library will be deleted. Go back to libraries. So now we see that Apid library is already being deleted. If you want that library to stay be created almost after every login, you have to do it manually. So let's create the library once again. Lib name apid underscore lib, and here is the location of our library. Right click on apid properties, Control C, semicolon at the end of this statement, hit run. A library being created, apid underscore library. But if we want this library to be created on the start of SAS, of every start of the SAS, what we need to do is we need to go back to our code. You copy that code, and then you go on the top right, you see this button with the 3 horizontal lines and 3 dots, which says more application options. You click on it and you go to edit auto execution file, and here you paste this statement. I'm sorry, don't save, we need the full statement from here. Go to the top right, edit execution, specify the SAS statement to run when the application starts, and here you paste this statement over here. So every time you log out of SAS program, and then when you log back in, this statement will be auto executed, and we hit save. So if we sign out again and launch SAS Studio right back, we'll see that Apid library will be created by itself this time. Here it is. Okay, and so after you have created your folder, after you have created your library, the next step is logically that you upload your data, which we have already done previously. So we'll keep it the way it is. And then the fourth step is that you convert the file into the SAS format. Just so you know, SAS cannot read any file other than its own format, which is recognized by the extension .sas7 bdat. Any other like Excel, text, CSV, etc., that they can be uploaded to SAS, but SAS can only work on its own format. Previously, we did that by just double clicking on it, and if you remember, SAS wrote the code by itself. But let's write the code because it's pretty simple. Let's delete this file and recreate it by writing the code. We'll go to the new button, which is the symbol of which is a square with an asterisk. Right, just click on it, new program, and let's start writing the code. The code for converting any file to SAS format is proc import, which is of course slightly misleading. It should have been proc convert, but whatever, we have to live with this now. Proc import, and as you can see, SAS is already guessing our next step. Of course, we want to write data file equal, and next we will provide within quotes the name along with the location of the file which we want to convert, which in this case is heart.xlsx. To get the name and location of this file, we can just right click on it, go to properties, and here is the name along with location. We just copy it, close, and then paste it within the quotes. Next, you have to tell SAS what you want to do with this file. What we want to do is we want to convert it into a SAS format file, which we want to save in Apid library. If you do not provide the library which one is saved, SAS will save it in the work library. You see here, it's one of the default library. The problem with work library is that anything created within this library will be temporary, meaning that it will be deleted at the end of the session and it will not be available in the next session. That's not what we want. We want a permanent created file in SAS format. So that's why we provided the library epid underscore lib. Next, you provide the name of your newly created file. Okay, one thing additional you need to tell SAS is what was the format of the original file. You do it by typing DBMS, which stands for Database Management System. The database management system for the original file was XLSX. You end the statement with a semicolon as always, and then you have to write an additional statement run, as is the convention in SAS, kind of a mandatory, except the lib statement where you do not need to write run. Any other statement, any other step has to end with run semicolon. Okay, that completes our step, and we'll go ahead to run. It's a good practice to check log. We see that it is all blue, which is good. And here is our output data. Okay, great. Okay, so what you see on your screen is the Excel sheet of the original data set that we uploaded in the beginning. We see that there are how many columns are there. We move the cursor all the way to the left until it changes into right arrow, and we see on the bottom there are 17 columns in this data set, and if you move the cursor to the top and until it changes to down arrow, we see that there are 5,209 rows, the top one being the header. Now next we want to see what lies within the data set in a snapshot. So let's do it in SAS. For that, what you need to do is you need to go to task, then data, and then list attributes, and this will open up a window on the right. Here it is already selected, but if it is not selected, you can always click on the table icon and go to the, to the particular data set where you want to check. And as soon as you click on that data set, you will see both the fields and the bottom will be populated, library being this, data set being this. You click OK. And on the extreme right window, you see that the code is already being generated by SAS. Now all you need to do is go to the submit button, this run button, and hit on it. And here you see the snapshot of the contents of that table. Here's the data name. There are 5,209 observations in that data set. 17 variables. This is when it was created. This is when it was last modified. If I can make it a little bigger. In the bottom table, particularly, you have all the details of your data set. And let's go over. So first column provides the column number in which that variable was residing, and the second column lists all the variables alphabetically. For example, the first variable was age at death, which is in column number 12. Next, in the third column, SAS is guessing the type of that variable. In that case, in case of age at death, it was a numerical variable. We'll talk more about numerical and character variable in the later sessions, but just to see over here, SAS has already guessed the type of each of these variables. In fact, what SAS does is it checks the first 20 observations and then guess the type of that variable from that. BP status, for example, is a character variable. Cholesterol status is a character variable. Cholesterol itself is a numerical variable, and so on. The third column provides the length of each of those observations. We'll skip the next two and let's move on to the last one, which is the label. If you see all the variables which are listed in the last column, they are the same as the second column. Age at death is the same as age and death, and so on and so forth. So why is that? Why we need to have two separate columns for variable and label? So here is the reason. When it comes to Excel and certain other data or certain other formats, they are pretty liberal. Excel is pretty liberal in giving you the liberty to choose your variable. It can be any number of, it can be any length, it can be hundreds of letters, characters. You can use ampersand, you can use percent, whatever you want as a to be included in the header, you can use in Excel. But in case of SAS, it is pretty strict. It only accepts maximum 32 characters for the header, and it only accepts alphanumeric or underscore as the header. So for example, if you have say ampersand in your header, what SAS will do is it will convert it into underscore. If there is a space even in between, for example, if it is age, space, at, space, depth, again, SAS will convert these spaces into underscores. So what will happen when you will create a SAS formatted table in SAS, what will happen is that the label will be according to the the rules which SAS abides by. If there was space, it will be appearing as age underscore at underscore death. If it was ampersand, it will be converted into underscore. And if it is more than 32 variable 32 characters, say it was 50, it will be cut down to 32 characters maximum. Okay, so this is one way of checking the contents of variables, but you can do the same by writing the code for it. The code again is very simple. You open a new program window. If it is not open, you can just go to the new button on the top left, the square with the asterisk, click SAS program, and simply write proc contents. Okay, next you do not need to write full data file, you just have to write data underscore, and now SAS is providing you all the libraries which are available. In our case, we are using epid underscore lab, which contains all our data sets. And as soon as you you type dot, it will give you all the tables which are available in that folder. In our case, so far we have only one table over there. The second one is not in SAS format, so we just write that. You end your statement with semicolon. As always, you end your step with run semicolon, and just hit submit. And now you see the same thing appear. In fact, there's one extra table, but the first and third tables are exactly the same with the same exact information. So pretty simple code for checking the contents of your table, right? Cool. See you next time. What proc print step will do, it will print the data set. Now you might wonder that you can always see the data just by double clicking on it, and it will open the table as you see on your screen. All the variables are listed, all the observations are listed. So why do we even need proc print? So what proc print does is that it creates the variable of your interest and the number of observations you wanted to see. So let's see what it entails. In fact, you can do the same thing by point and click by going to task in utilities, clicking on list data, and then in under the tab data, under setting rules, you can starting from the top, you have the data already selected, epid underscore lib dot hard, and in the next section you see roles, list variables, and if you click on this plus button, you will see all the variables in your data set, and you can pick and choose the ones which you want to see. For example, in our case, I want to select 5 or 6 of them. For that, you press and hold control button and start clicking on all the variables you want to include. And the status was already selected, so it got unselected. I'm going to select it again. I'm interested in seeing the age at which the chronic heart disease was diagnosed, the sex of the patient, age at the start of the study. I want to see their say smoking status, systolic and diastolic blood pressure. So all these 7 variables I want to see, I will include them over here. I'm not gonna use any of the other options. Next, I will go to the tab option. Instead of all rows, let's see first 100 rows. I just want to analyze the data. I'm just eyeballing them. And if you see in the window on the extreme right, it has already the code proc print data. The data set observation within the parentheses labels, which in our case are the same as they are in the data set. Next statement is called the var statement from var, which stands for variable, and these are the variables listed. The statement ends by semicolon as always, and then run statement. And if you see closely, you also see the SAS program itself is creating the title for that table. All we need to do is submit this code. And as you can see, the table contains first 100 observations of the variables that we selected. You can do this very conveniently by writing the code, which is again very simple. You open up a new program and just write proc print data equals, and here are all libraries which are available, append_lib. As soon as you type dot, it will have all the data sets available in that library. And just end the statement by semicolon and add the statement run as always and hit submit. So it is taking a long time to upload the data, and that's one of the things which you need to deal with when you are dealing with well, this is just 5,000 plus rows, but sometimes you have millions of rows which can take substantial time. In our case, it just took say 10 seconds or so, depending on the speed of your computer and your internet. It is a good practice to check the log. It is all blue, which is good, and you see all the results here. Okay, so but what if we want to choose some specific variables? That's what you do. Okay, my computer is again frozen, so I'm going to pause this video until this freeze is over. Please bear with me. Okay, while the video was paused, it took good about 1 minute for this freeze to be over. So that's one of the challenges when you're dealing with large data set. And for those reasons, if you have millions of rows in your data set, you do not want to see all of the data just for the sake of eyeballing it, because it will take a very long time for that data set to be uploaded. So we want to see first 100 observation. For that, you just need this code in the first statement in your step. Observation equals 100. So we just want to see the first 100 observations. And in the next statement, it is customary to add a space just to make it easily readable. Just hit tab and it will give us the right amount of space there, and then you write variable. Now you can type the variables you want to include, but there is a quicker way. You go to libraries, my libraries, and then scroll and then go to the data set where it is which you want to see. You go to hard data set, and then again you press and hold control button and choose the variables you want to include. Again, we would like to include status, we want to include age at the time of death, we want to see their systolic and diastolic blood pressures. What else? Maybe age at the start of the study, age at chronic heart disease, and then you just drag and drop them in front of var statement, and here they are, and they are in the sequence you click them. So that's pretty. And then you end your statement by semicolon, and that's all. You hit submit button. And this time it took much less time, maybe 2 or 3 seconds. And these are the variables of our interest, and these are the first 100 observations. Proc means step. It provides, as the name suggests, the means of the numerical variable. Of course, the character variables will not have a mean, but in addition, it also provides you with the standard deviation, minimum or maximum values of all the numerical values in your data set. So let's do it first by point and click method, and then we will write the code, which again is very simple. For point and click, go to task and utilities, and next you go to statistics and then summary statistics. In the middle pane under tab data, and then the section data, the data set is already being selected, but if it is not, you can always go to the place where it is which it is saved. In the next section, you see analysis variable. If you click on the plus button on the top right, it will give you all the numerical variables in your data set. You can choose them by pressing and keep holding control button and then clicking on the variables you want to include. I want to see age chronic heart disease was diagnosed, age at the start of the study. I want to see say diastolic and systolic blood pressure of the patients, and that's all. Okay, and all these are now selected here, but you can also rearrange the sequence of these variables according to your need. Let me move age at the start to the top. I will click on it. It selects that variable, and I will move it on the top. The rest of them are good. Next, I can also classify the way I want these variables to be analyzed. Let me analyze them first by sex, male and female, and next I also want to see them by, say, I will look at them by their weight status. Okay. And you can also go to the option and choose a bunch of things over there, mean, standard deviation, minimum, maximum, number of observation. I will uncheck all of them for now. You can even see a histogram or other box plot for these variables, but let's leave them out for now, and let's see what SAS has got for us. Okay, so as you see on your right, the first column has divided all the values between males and females, and the second column by their weight status. And what we see in the first row is the mean for females who were normal weight. We have 846 such females. Their age at the start of the study was 40 years, and age at which the chronic heart disease was diagnosed was 64. Diastolic blood pressure mean was this, and systolic was this. And for overweight females, we see that their age at start was slightly higher, 45. The age at which they developed chronic heart disease was 65. Maybe it is biased because many of them, they started late in the study. Diastolic blood pressure is higher than those who were normal weight, which makes sense. And the systolic blood pressure is substantially higher than those who were normal weight, and so on and so forth. And so same with the male individuals, normal weight, overweight, and so on. Okay, so that gives you a good understanding of the data you are dealing with. But we can do it by writing the code also. So let's do it. You can go back and open a new program. In fact, you can also do it by a shortcut that is F4. By clicking on F4, it will also open up a new program window. And you can now write proc means data equals, and here are the libraries which are available to us. And as you enter dot, it will give you all the data set, and hit semicolon to finish the statement, add a space for better legibility, and here you can add all the variables you want to include. You can always type them, but for sake of avoiding any errors, it is better to go to libraries and choose the variables of your interest. Okay, and the cool thing over here is that they will be selected, they will be listed in the sequence you select them. So press and hold control button, age at start, age, chronic heart disease was diagnosed, diastolic blood pressure first, and systolic blood pressures second, and then you can leave the control button and just drag and drop them in front of var statement. Finish the statement by a semicolon. Next, you can classify them by adding the code class, and we want to class them by first sex and number 2 by their weight status. Close the statement by semicolon and close the step by run statement semicolon, and that's all you need to do, and hit submit. Okay, so the same information is now available here. The only difference is that it by default SAS is going to include standard deviation and minimum and maximum value of all those numerical values variables. Thank you very much. Okay, so proc univariate step is in fact the extension of proc. Means it provides much more information than just meaning and some of the basic information about any numerical value, as we'll see in a minute. This time let's write the code first, and then we will compare it with the point and click method. There's no direct replacement of the code in the point and click method, but there is a way around, and we'll see that in a moment. Okay, so let's write the code first. Let's open a new program window by function F4 and start right. Okay, let's start writing for proc means first, and then we'll see how it differs from proc univariate. Proc means data equals epid underscore lib dot heart semicolon, and then we finish the step by adding the run statement and hit submit. Okay, so it is now providing us the means of all the variables in numerical variables in our data set. Let's stick to just one. And add a space to make it more legible. Var statement. Let's include only age. Chronic heart disease was diagnosed. Semicolon. Okay. Now you see here that there were 1,449 patients who were diagnosed with chronic heart disease. The mean age was 63, and here's the standard deviation of that. So let's replace it with univariate and see how it is different from means. Univariate. Okay, let's hit submit. Okay, now you see that it has provided a whole lot of information about that one particular variable. Here is the number of patients who were diagnosed with chronic heart disease, their mean age, standard deviation, a bunch of other things. And if you see on table second, it is also providing us the mean and median. And fourth table is it is providing by percentiles and quantiles. We'll learn more about percentile quantiles in the future sessions, but just look over here for now. The 10th percentile was 51 years of age. The median was 63, which is in fact exactly the same as median, which is amazing. Normally you do get some skew on one side rather than median is slightly on one side or the other. And in the fourth table, you see the extreme values. On the left side of this table, you have the lowest extreme values. For example, um, someone was diagnosed at the age of 32, and this is the observation number 1648, or the row number 1648, or the patient 1648, whatever you call him. And on the right, we have the extreme high values. Someone was diagnosed at the age of 90 also. This observation number is this. And then we have around 3700 values which were missing. Okay, now let's see how we can get this information through point and click method. For that, you need to go to task and utilities, and then under statistics, you go to distribution analysis, double click on it. Under data tab in the middle pan, you see that the data set has already been selected. If not, you can manually do it by clicking on the table icon. And under data, you have the roles section. Let's add only chronic heart disease over here. You can also go to the next tab and click on a few other things, but we will leave them out for now. And let's see what SAS have for us if we just go with this information for this code. Okay, so we see that instead of giving us all the information, it is in fact providing us the histogram. We see that someone was diagnosed at a pretty young age at 33, but most of them were around the age of 60 when they were diagnosed with chronic heart disease. And as expected, lesser and lesser number of patients were diagnosed with chronic heart disease at the later age. And here is the one who was diagnosed at the age of 90. To get the information which we saw through the code, in fact, we can manipulate the code which was created by SAS by editing this code. You see this button on the top, edit. You go to edit and simply just remove this ODS select histogram. And if now we submit this code, it should give us a whole lot of information as we saw directly from the code. So it's the same thing which we received through writing this code. We got it over here. At the end, it is also providing us a histogram, which is in fact nice. It's a nice visualization. In fact, we can add this histogram in our code also. For that, all you have to do is just add another statement under var statement that you need a histogram of age chronic heart disease diagnosis, and that's it. And hit submit. It should give us the histogram at the end. Pretty cool, right? Okay, see you next time. Okay, so far what we have learned was about the numerical variables, but what to do with the categorical variables. You might already know the difference between numerical variables and the categorical variables very obviously. The numerical variables are numbers which can be divided, multiplied, added, subtracted, and then the character variables, of course, cannot be cannot have these mathematical functions. And if you see in the middle pan over here, SAS has already recognized them and ascribed them the specific category. For example, status, if you see on the left of it is there is a pine tree with a A letter in the center. That's a categorical variable. Then that cause, again, A represents a categorical variable, age, chronic heart disease, and you can see it over here. These are the numbers. So SAS has correctly assigned it a numerical symbol 1, 2, 3, and kind of this egg-shaped circle, and so on. So how do we analyze the variables which are in fact categorical? They are categories when we cannot really get the mean out of them. So what we do is we get the frequency of them. So that's where we use the function proc freq. Let's do it by point and click method first. We go to task and utilities, and then under statistics you see the option table analysis. Double click on it. In the middle pane under data, you confirm that the data set of your interest is already selected. Next section, rows. Under row variables, you click on the plus button to add column. So in fact, SAS doesn't care if you want to get the frequency of numerical or categorical variables. It will give you, but it does not really make any sense to get the frequency of, for example, age at the start, because there can be, say, 100 categories for age, and we do not really want to know how many of them were, say, 5 years of age, or 6 years of age, or 30 years of age, or 31 years of age, and 30. What we can do is we can convert these numerical variables to categories, like 1 to 10 can be 1, 11 to 20 can be second, and so on and so forth. In fact, there is some categorical conversion of the numerical variables, which I noticed. For example, if we go back to the data set and we uncheck all of them, I noticed that the smoking status, for example, over here, and smoking, the second column on the right is in fact the derived kind of variable, which has been driven from the number of cigarettes anybody was smoking. Non-smokers obviously are the ones who are not smoking 0 cigarettes. Those who are smoking, for example, 10 cigarettes, they fall in the moderate category of smoking 6 to 15 cigarettes per day. Heavy smokers, it's going to be subjective, but the researchers assigned anybody who smokes more than 16, in fact, between 16 and 25, they assigned them to this category, heavy smokers. So this guy was smoking 20 cigarettes, God forbid, so he was among the heavy smokers, and so on and so forth. So there's a way we can check the frequency of even the numerical variable, but in larger sense, we do not really need to check the frequency of those. So for the purpose of learning, let's select some of the categorical variables from our list. The status, in fact, represent somebody, if somebody was alive or unfortunately dead. We select this. To select multiple, you can press and hold Control. What else do we want to know? We also want to know how many males and females are there in our data set, and maybe we would like to see how many of them were normal weight, underweight, overweight. You choose all of them, click OK, and they are there. You can change their sequence. We do not need to do it for our purpose over here. Next tab, option, you have multiple things you can do over here, but we will, for now, we'll keep the default one. In fact, let's choose cells. It will give us the percentages by cells, and we'll see. And in fact, if you see on the right, the code keep on changing as we change the options. For example, if I uncheck cell again, you will see that it is no more there. But if we we select the cell, then this code has changed. We do not need the chi-square statistics because we have not learned that yet. So we are going to uncheck it, and that is gone from here. Let's click submit. Okay, so now we see that among the status, 61% of our patients were alive at the time of collection of this data, and 38% were unfortunately dead. And here is the histogram of it. We see that in our data set, 55% are females, 44% are males, and we see that a large number of patients were in fact overweight, almost 68%. And we'll talk more about this bias later in our course, why there were so many overweight people in this data set. Maybe because they were already concerned about their chronic heart disease status. So they might have volunteered for this study more than the others. So that might represent, or maybe there is already the problem of obesity in this population. There are multiple reasons why we have so many overweight individuals in our data set. Now let's create the same tables by code. For that, we are gonna open up a new program window by F4, and let's start writing proc freak data append underscore lib dot hot at the end the statement by semicolon. We add a space to make it more legible. Okay, in proc freak, in fact, we do not use the var statement. In fact, we use the tables because that's what you are going to get as a result. So we write table, and then we add all the variables which we want to include. Again, let's choose the ones we selected for point and click method. Those were and the sequence with which you will choose them are going to be populated over here. So press and hold control status. What was the second which we were interested in? Sex and the weight status, and then just drag and drop in front of the table, and the statement by semicolon, and the step by run statement, and hit submit. Okay, so here we are getting the same results, slightly differently. By default, SAS also include cumulative frequency, which is not going to hurt us. Okay, thank you. Cross tabulation is an important function and very useful in data analysis, especially when we want to see the frequency of certain variable broken down by certain other variable. For example, if we want to see, let's think about it. If we want to see the blood pressure status in those who are normal weight, high, above normal weight, or underweight individuals, we can see this through the cross tabulation function of SAS. To do that, let's do it by point and click method first. Go to task and utilities, and the statistics, go to table analysis again. Double clicking on it. Under data, our data set is already selected. Under roles, we add in the column, let it be the weight status, and the column variable be blood pressure status, BP status. We will be observing, we do not want to see the frequencies, we are interested in the percentages, and that too by row at this time. Chi-square we are gonna uncheck for now, and let's see what SAS gives us over here. We want to suppress the plots for now. These are not going to give us any useful information at this point. Okay, so if you see here, I'm sorry about that. Okay, among the normal weight individuals, we see that 26% had high blood pressure, 47 only 47%, only for 26% had high blood pressure. Almost half of them have normal blood pressure, and 25% had optimal blood pressure. Good statistics for those who were normal weight individuals. But for those who were overweight, 51.8% had high blood pressure, and way less than half, that 37% had a normal blood pressure, and only 10% of them had normal blood pressure, and so on. We can do the same thing through through the code which we created previously over here. What we can change over here is we write first the weight status underscore status, and then multiply or asterisk by blood pressure underscore status. Let me confirm that I am typing it correctly. The easier way is you go to the library and choose the variables directly from the drop down list. That's a better way of doing it. Luckily weight status is fine, and as far as the BP status, that's fine too. Okay, let's go ahead and submit this code. Okay, so this is the same table, but by default SAS is giving us the frequency, the percent, the row percent, and column percent, but we are not really interested in these two and the last one. So we can express it again through the code. To do that, just add forward slash and then start excluding the one which you do not want here. No percent, we do not want overall percent, we do not want them by column, no call, and we also do not want the frequencies. They are of no use to us at this point. We just want to see the row percentages here, and submit the code. And now you see it is in fact exactly the same way we created them through the point and click method. Many a times during research, we have the data set, but we do not want to work on all of the individuals in our data set. We want to work on a subset of them, or there are certain other reasons. There might be some other reasons for which we do not want to analyze the full data set. We just want to have certain individuals or certain observations which we want to see how they are. What is the frequency, what is the mean, etc., in a particular subgroup of those observations. For that, we use a filtering function. In the code, it is done by where statement. But let's see by the point and click method first, and then we'll write the code first. Okay, so to do that by point and click method, go to task and utilities, go to data, and then you double click on filter data under data. Okay, so here is the wizard which will help us choose the choose the subset of our data. Let's suppose we want to see only the individuals who have hypertension. Okay, so here is the full data set with 5,209 observations, but we want to see only those individuals who have high blood pressure. For that, what we can do is we can just Google. Okay, let me just Google the definition of hypertension, and then we'll go from there. Because this definition keep on changing. It's quite complicated. A complicated definition of hypertension. Okay, I'm just gonna click on. Let's go and see what CDC says about high blood pressure. Okay. So over here we have the definition of high blood pressure. Systolic blood pressure 140 millimeters of mercury or higher, or diastolic blood pressure of 90 millimeters of mercury or more. So let's choose the patients who were having these values of systolic, diastolic variables. So for that, we'll go back to our data set, go to filter. We know that this data set is already selected, and let's select systolic. Okay, and the comparison could be greater or equal, and we are going to enter a value here. The value as was given in the CDC website was 140, or the second variable could be diastolic, and its value should be greater or equal to 90. Okay, so that these were the only two requirements. We also do not want to mess up with the current data set. We want to create a new data set, so we do not ruin our original data set, because we might need it in future. So we are gonna create this new data set over here. Let's create it in the same library, appid_lib. We know that if we do not provide the library, SAS is going to create a new data set, but it's going to create it in work library, and it will be deleted at the end of the session. That's of course we do not want. We want to create a data set which we use in the future. So here is the library, and let's name our new data set as heart_hypertension. Maybe let's just name it hypert. Otherwise it will be too long, and let's submit the code. Okay, so if you see on the leftmost panel, we see that a new data set has already been created, which is the name which we have given it. And on the right side, we see that that data set itself. Let's see if SAS has done a good job or bad job. So let's just see systolic, diastolic, and let's see the BP status also. So we see that all the individuals now in the data set have either diastolic blood pressure above 90 or systolic blood pressure above 140, for example. Over here, the diastolic pressure is okay, but the systolic pressure is really high, and same with this poor guy, and so on and so forth. Okay, so we can also do the same thing by the coding method. So let's go and write that code. Okay, now what are we doing? So far what we have done is we have only worked on the same data set, and we ran the different procedures. So that was why we were using proc steps. But now we are literally creating a new data set. We are manipulating the data. So as we learned in the beginning, this is a data set, and it starts with the word data. Slightly change again here. We are going to provide the output data first and input data set second. So the output data would be appid_lib dot, that's the library where it's going to save, and let's name it again heart_hypert. Oh, in fact, we have to delete this one to avoid any errors, and we have to then run the code again. Let's delete it, and we just close the statement by semicolon, space, and now we provide this data set from where we are gonna pull this information, which is again appid_lib dot heart, semicolon. Okay, now here we are going to provide the information to SAS which variable, which rows to include, and we're going to start with where systolic is greater or equal to 140, or diastolic is greater or equal to 90. This was the definition, right? Oh my goodness, it's 80. Okay, it's okay. We are gonna just use 90 for now because it's gonna mess up a lot of things. Let's use 90 again. Okay, and just run the code. Okay. If you see back in the point and click method, we had how many patients having that many that equal those who were hypertensive to 2432, and by coding we also see the same number of individuals who have hypertension. And if we see at the results, at the output, we see the data set, and on the left panel you see that a new data set has already been created, right? Okay. Okay. If and then statement in SAS is very frequently used feature. It is mostly used to create a new variable. Let me give you this example and it will make it clear to you how this can be used. Okay, let's suppose, okay, let me show the data set first. Here's our original data set, okay? And here is the BP status, and this is the systolic blood pressure and diastolic blood pressure. Suppose American Academy of Pediatrics changes the definition of hypertension now. Instead of the original definition that somebody who's having above 140 and 90 millimeters of mercury is considered hypertension, now they say that anybody who has above 130 millimeters of mercury is considered high blood pressure, considered hypertensive, regardless of his diastolic blood pressure. So in that case, our original blood pressure status given many years ago is no more valid, and now we need a new variable which assigns them the blood pressure status according to the new definition. So let's do it by point and click method, and then we'll do it by coding. Okay, so to do it by point and click, we go to task and utilities, and we go to recode ranges, opening up a wizard. On the data tab, the data set has already been selected. The variable which we are going to use for the new definition is systolic only, because now the new definition is based on just one variable, systolic. And we are going to create a new variable here. Let's name it blood pressure status new, or let's name it blood pressure status 2. And we are not going to ruin our or mess up our original data set. We're going to create a new one. Let's name it, we're going to create it in the same library, rapid underscore library, and let's name it heart underscore blood pressure new. And here, and next tab, value, here are we going to provide the values, the new values. Let the lower bound be 0. We know it's not biologically possible, but we want to capture all the values in systolic blood pressure which are below 130, and upper bound will be, say, 129. Okay, and anybody who has below 130 millimeters of mercury systolic blood pressure will be given the status normal, and anybody who has 130 millimeters of mercury to, say, 500. Again, 500 is a very high value. Nobody can survive this high blood pressure, but we want to capture all the values. They will be assigned the status, BP status of high. Okay, that's all. And you see on the right, this SAS has already created that code. We run this code. Okay, and we see that a new data set should be created. Okay, here, this is a new data set which has been now created. And if we see there is a new variable, BP status 2 is now created. And if we compare it with the previous one, blood pressure status, systolic, okay, we see that this individual who had 132 systolic blood pressure was considered normal previously, but now he is considered to have high blood pressure. Okay, let's do the same thing by coding. We open up new SAS program and we start writing our code because it is a data step. So we are going to start with data append underscore lib dot hot. Let's name it underscore BP new 2 because we already have one BP new data set in our folder. Okay, next we end this statement by semicolon. Next we have to provide the set to use this new data set, which is going to be the same one, epic.lib.hot. Okay, close the statement by semicolon, and now we'll provide the if and then statement. If systolic is less than 130, then BP status, that's the new variable we are creating. BP status 2 is normal. So if you notice, if we are creating a new variable and it has a character, it is not numerical, it is a categorical. We provide those characters within colon. If it is a numerical value, we do not need to provide them within quotes. Okay, we close the statement. Next would be else. Anybody who is not, who doesn't have less than 130 millimeters of systolic blood pressure will be considered high. So then anybody who has BP status of 130 or above 2 will be considered high. Okay, and close the statement, close the step, and let's run this code. Okay, and as you see, as further new data set is now created, hard underscore BP new 2.SAS7 bdot, and here is that data set, and let's check if SAS has done a good job or not. Okay, there is the new blood pressure status. It has created 2 new variables, in fact, because BP underscore status, it has a bad spelling here. I'm sorry about that. Okay, let's run the code again. Okay, now we have only one BP status 2. Awesome. Okay, let's check. BP status 2, BP status original, and here is the systolic blood pressure. And let's see anybody who has about, okay, here is the person who has 132 millimeters of mercury. He was considered normal previously, but now he has high blood pressure. Okay, thanks. Okay, now you have created a new data set with a new definition of blood pressure. Suppose now you have to send this data to your boss, to your colleague, or anybody else with your team, and how you're going to export it to them. They might have SAS, they might not have it. You want to convert that data set to more commonly used CSV or Excel file, and that can be very conveniently done within SAS also. Let's do it by a point and click method first, for which you will go to libraries, my libraries, and navigate to where your data set is saved. This is the new data set which we created. Just right click on it and hit export. Okay, SAS is asking where do you want to save this data set. Okay, we are going to save this new formatted data set again in the same library epic. And if you see in the bottom, you can even rename it whatever you want, but let's keep the name heart underscore BP new 2 because it will anyway have a different extension, so it's not gonna give us an error. And in the bottom you see different formats where you can on which you can convert this data set to CSV and space delimited, tab delimited, etc. Let's convert it into the XLSX format. Okay. Once you change the format, you might have to choose the library one more time and just hit export. Okay. And if we go back to our original library, you see that a new XLSX file has already been created. Let's do it by the coding method now. For coding, you go to the code and let's start the code. Again, this is we are not really creating a new data set, but we are creating we are in fact exporting. So it's a proc step, proc export. Now you provide the data set you are going to export. Data equals append underscore lib dot, and now we see that there are 4 data set which we have created. We want to export this with the new blood pressure status. Next, you have to provide the out file name and its location where you want to save it. Okay, so we want to save it in the same folder. So you have to provide the location of that folder, and it has to be within the quotes. Control V, and also provide the name of the new file. Let's name it heart underscore blood pressure new 2. Okay. Okay, so it is going to give us an error because there is a similarly named data set over there. One way to go around it is to add the statement replace. This is going to replace this data folder. Oh, okay. I forgot one more thing. You have to also provide the format of your output file, which in this case will be XLSX file. So let's provide the DPMS, which stands for Database Management System, and the output file output file will be XLSX file. Replace and the statement by a semicolon, and hit and end this step by a run statement and hit run. Okay, and okay, so it is created, but let's make it sure that it's the new one which we have just created. And it's slightly differently worded, but let's delete both of them and run the code again to make sure that it has worked perfectly. Okay, let's run the code again. Okay, here it is created here, right? Okay. To export this file, you just have to right click on it, and you can download the file on your computer over here, and send it by email or print or whatever you want to do with this file. Okay.